recall that pointers are variables. They just have this special data type assigned to them, that they're variables designed to contain addresses of other objects. So const can be used with pointers. And so let's just go over some examples of using constant keyword and pointers. In this code example, we create a double value, and we also create this constant double variable. So this double is a constant. Then we declare a pointer, and this is a pointer to a double. So then we can also declare a pointer with a constant keyword like this. Remember that all C++ declarations of variables can be vocalized in the right to left direction, in the progression from right to left. And you start with the name of the variable, and then you say pointer to CD is, or PTR to CD, the name, the identifier of the variable, the name of the variable, is a pointer to constant double. Okay, and likewise, this first pointer is a pointer to double. So these are two examples of pointers that we use here. And then we say, okay, let this pointer, okay, now I will try to do some drawing right here. So we say that, is this okay for this pointer to double, to point to a double? Yes, it is. So we just basically say, okay, this is fine. Pointer is a pointer to non-constant double. This double is not constant, just normal double. So we could use this double in any place to change this value. Now, in other case, when we say, let's take address of CD, which is also a double, and give it to a pointer which was declared not a pointer to a constant double, this will be an error. Address of const can be assigned to non-const pointer. So there is a restriction like this. So remember that when you use this assignment operator, C++ compiler, and especially with pointers, will try to make sure that the data type on the right hand side matches the data type, or can be very closely converted to the target of assignment, to the left hand side of the assignment. So here this const keyword breaks the rule. However, a pointer to a constant double without restrictions can be assigned to D. We're just saying, okay, this pointer will not be able to modify D, or to CD, which is by its declaration is a constant. So in these two cases, this pointer can point to both of these doubles in memory. It's not a problem. There is a second type of use of a constant keyword with pointers. So it's like a second version of the previous set of examples. So we continue to use two of our double values. One is just plain vanilla double, and another one is a constant, right? So this is constant double 4.5, which means that once created, its value cannot change by definition, by design. So first example is that we create a pointer which is called cptr, okay, and let's explain what its type is saying right now. Now compare it with here. We created this pointer which was a pointer to a constant double. Now here we have a pointer which is constant, right? So we say cptr is a constant pointer to double, right? So this const keyword applies to the pointer variable itself. It declares this variable to be constant. Therefore, once it's assigned the value, it will not change. And of course, D is a normal double, not constant double, so there should be no restrictions. So here there will be no restriction of no restrictions using C pointer, CPTR, this constant pointer, to change value D. However, it will not be possible to assign another address of another variable to this CPTR, because once again, if you start with the name of the variable and move in the right to left direction and vocalize everything provided as a type of this variable, you realize that CPTR is a constant. So this thing is constant. It cannot change after initialize. So CPTR is a constant pointer to a double. Okay, so we have a double and we initialize this pointer with an address of this double, and it's fine. Now CPTR initialized with address of a constant double is not possible, because it's in itself CPTR is a constant pointer to double, but you cannot initialize it with an address of a constant double, because supposedly this constant pointer could still be used to change this value, which by design is not allowed. So what you need to do, okay, so you need to if you want this, okay, you have to say the properly, you have to say CPTR2, which is the name of the variable, is a constant. So this variable itself is constant, which means it can be initialized, but it cannot change. It cannot point to something else. I repeat, CPTR2 is a constant pointer to double, which is in itself constant. So now we have been able to create a pointer which is pointing to a constant double, right? So this pointer is a constant, and it's pointing to a constant double. So it cannot be pointing to actually, I'm sorry, I just was gonna say something else, but it's okay to use D in constant context. So it's okay to initialize the CPTR2 with address of the double. And notice again, because CPTR is a constant variable, you have to initialize it. So you cannot declare it without initializer. You have to provide the initializer